Hello everyone, today we are going to work on solving a system of equations by elimination. This is the last of the three ways to solve a system of equations, and U10 will cover it on IXL. So let's go ahead and get started. Get rid of this. Okay, solve a system of equations by elimination. That's what we're going to do. Okay, so let's go ahead and work on a bell work that was assigned for this real quick. You're not really going to understand this, but I want to show it to you, and then I'm going to explain to you what I did. So by eliminating, I'm going to have to get one of these letters by themselves. Well, I already see that I could take a 2x away from a 2x. So basically what I'm going to do is I'm going to take everything in the second linear equation and just multiply everything by -1. And if I multiply everything by -1, all that does is change the signs. That becomes a -y, a -2x, and then a -3. Now I'm just going to kind of add this whole thing to this whole thing. So 2y minus y becomes y. 2x minus 2x just becomes 0. And then 3 minus 3 becomes 0. So I know that y is equal to 0 plus 0, or y is just equal to 0. So there's one of my two coordinates right there. It is my y coordinate, and it is equal to 0. And just like on the other ways, once I find one of these values, I can plug it in for one of the other ones. So I'm just going to go ahead and plug it into the second one. The second one started out as y is equal to 2x plus 3. And what y is, well, it's equal to 0 where those two lines cross. So I know that 0 is equal to 2x plus 3. Now I need to get the x by itself. So I'm going to take this 3 and move it over here. It becomes a -3. And -3 is equal to 2x. I'm just going to divide 2 out of both sides. And I end up with -3/2 is equal to x. So x is going to be -3/2. So there are the coordinates of where those two lines cross. That's just a quick example. Now I'm going to explain a little bit more in detail what it is that we're doing here. Okay, so elimination. That's how we're solving this. To eliminate means we're going to eliminate one of the values, which means one variable, make one variable go away. That's what elimination means. So in that example, we made the x go away so we could solve for y. And it depends on how the problem is set up, but we're going to look at a few examples here. So elimination just means make one variable go away. So let's look at an example. This one is already set up for it to happen. This one's already set up for it to happen. I can already see that 7x minus 7x, that makes it go away because 7x minus 7x is 0x or just 0. So that makes that go away. Okay, here I have 2y minus y. There's that bell again. 2y minus 1y is just 1y or y. And 5 minus 4 is just 1. So I already know that y is equal to 1. And again, I'm just trying to figure out what one of those two values is, and then I can plug it in to find the other value. So I know that the y is 1. All right, so now I can either plug that 1 in here, or I can plug that 1 in here. I'm going to try to avoid the negative, so I'm just going to plug it into the first one. It'll work on either one. Okay, 2 times y is 1. That's what the y is where these two lines cross, is equal to 7x. This is where I'm getting this right up here. 2 times y, 2 times 1 is equal to 7x plus 5. All right, 2 times 1 is just 2. So 2 is equal to 7x plus 5. I'm going to take 5 away from both sides, or move this 5 over here, and it becomes 2 minus 5. So that's -3 is equal to 7x. And then I'm going to divide 7 out of both sides, out of both terms, and I end up with -3/7 is equal to x. So -3/7 is the x value where those two lines cross. Of course, I really wouldn't have been able to see that very well if I was trying to use graphing. Okay, so that's one example.